we go, lesson 12.4. Okay, so we're still doing trig, but I want to show you those reciprocal functions I didn't show you. And there's three of them: cosecant, secant, and cotangent. And they're called reciprocals because that's what they're going to be. If this is sine, then cosecant's going to be 1 over sine of theta. Okay? Alright, it's really simple. All you got to do is go back to the answer we got for this example. It says sine of theta is a over c. You see the word reciprocal, and you are literally just going to flip it to the reciprocal, c over a. Okay? You want secant, it's 1 over cosine. It's the reciprocal of cosine. You go c over b. You want cotangent, that's a reciprocal of tangent. You go b over a. Okay? And if you really want to know why, just real quick, I'll show you why. Well, when you have the answer for sine of theta is a over c, and you want to do the reciprocal, you're creating a complex fraction. Yeah, I had to do a plug-in there for a complex fraction. All right, so this is really 1 divided by a over c. Well, anytime you divide fractions, you leave the first number alone, you change it to times. Remember how you flip it good? You've been doing that since probably 6th or 5th grade, okay? Well, guess what? It works. And that's why the reciprocal of a over c is c over a, okay, because you're actually dividing. Okay, so you got 3 new words: cosecant, secant, cotangent. Let's go to the other example we did on the last lesson. Number 9, remember we had to do the Pythagorean Theorem, and we found this missing side was 34. And then look, we only did those 3 ratios. Well, look, I've got sine of theta is 8 over 17. I want the cosecant. So I'm just going to flip 17 over 8. Flip it good. Okay? You've got cosine of theta is 15 over 17. You want the secant. Okay? So you're just going to flip it 17 over 15. Alright? And then finally, for the last one, you want the cotangent. So the cotangent, you flip it and you got 15 over 8. Okay? If that seems simple enough, good. I want it to seem like it's simple enough. Okay? It's just 3 more definitions. Okay? There's more for us to learn, right? Exciting stuff. So let's just do one more problem. Make sure you guys are good with all this trig. Like I said, you saw it last year, and a lot of you kind of really liked it. All right, I picked out a problem that I wanted to do, and I think I want to mess with number 7, is what I'm thinking. So let's see if I can zoom in faster than normal. Yes! Put that baby right in the middle. All right, let the party begin. We're now going to find all 6. Okay, so first of all, got to be a right triangle. It is a right triangle, okay? They gave us, what, 2 of the 3 sides, right? So that's good too, because we can do the Pythagorean Theorem. So c squared equals a squared plus b squared. Alright, they gave us the legs. So c is the one that's missing. Oh my god, they made this one really nice and easy. So 5 squared plus 12 squared. C squared equals 25 plus 144. When you're looking for the hypotenuse, you add first. That's 169. Square root, c is 13. Alright, who can tell me why that's a pretty legitimate answer? Excellent, yes. If I get the hypotenuse, that answer 13 has to be larger than either of the legs. Because remember, the hypotenuse is king. Nice. Okay, now we're going to label for trig. It's all about that acute angle. In this case, they're using just theta. They didn't give you a number. We're going to label. I would label the hypotenuse right away. You guys tend to not get that one wrong. The one that drives y'all insane is the opposite and the adjacent. Well, who makes theta? Doesn't theta? It's created by 13 and 5, so both of these are adjacent, but that one already took hypotenuse, so then this is adjacent. Who's the only side not making theta? That's 12, so that's why that's the opposite. Or if you're swimming across the lake, okay, you're going to the opposite shore, okay? Let me circle that. All right, here goes your trig functions. SOHCAHTOA. Just write it. Always write it on your paper. Just write it, write it, write it, write it. Or the one y'all do, some old hippie caught another hippie tripping on acid. Whatever, as long as you get it right. Okay, here we go. So sine of theta. So the sine of theta is opposite, which is 12 over hypotenuse. I got this. All right, cosine is adjacent, so 5 out of 13. Okay, notice, both of those have 13 because sine and cosine are over hypotenuse. Tangent will not have 13. Tangent is O over A, so it is 12 over 5. Okay? Now, all you got to know is which one goes with which one. Okay, cosecant is 1 over sine, so flip that answer and flip it good. All right? Secant is 1 over cosine, so 13 over 5. And finally, cotangent, all right, is the inverse of tangent, so flip it, good, 5 over 12. Okay, again, this is Mr. Mack. You're probably tired of me already. Lesson 12.4, page 2. All right, please take it easy.